Thanks everyone for joining the Future Proof podcast. My name is Alex Mysinek. I'm joined here with Robin. He is the founder and CEO of Power Intelligence. We're just going to go into a little bit about his business, what they do, and then talk about industry's trends. So thanks, Robin, for joining me.
Of course, Alex. It's a pleasure.
Absolutely. So why don't you go into just about what Power Intelligence is about, what you guys do, and how you help your clients?
Sure. So we have a suite of software tools that are used to analyze radiometric or thermal images and analyze also the data that they produce over time with a proprietary algorithm that's useful to allow for measurement with thermal imaging sensors at significant distances, as opposed to the traditional manual method of using handheld instruments, which you have to be very close to the thing you're measuring. We have a patent on the technology that solves that problem and allows us, with the most recent version of the product, we can now take measurements that are accurate to within a couple of degrees out to distances of about 600 feet, which dramatically increases the performance or the value, if you will, of the very expensive sensors that are used to do this. So now, and these latest ones happen to be rotating cameras, are called pan and tilt cameras. So a 600-foot range gives you a 1,200-foot diameter. That can cover a huge amount of equipment in a substation. So you really get maximum value of this technology out of that method of deployment.
Got it. And so like traditionally, if they're not using your guys' technology in, analyzing that, what are they doing now? Like you said, they're going around and like manually like taking a camera, pointing it at things and like registering that data down on like a notebook, or what's that kind of look like?
You're not far off. I mean, that's a pretty close description of how it's done. It's called periodic inspection, and it's done with a handheld instrument. Looks a little bit like a flashlight, and you can point it at the thing. There's a screen, and you can record the temperature that is indicated on the display. And they have a variety of features where it will store the image, it will transmit the image, etc. That's what's broadly referred to as thermography. So a thermographer will typically be, a person in industry who is responsible for reliability or maintenance of either electrical equipment or rotating equipment, things with gears and motors, both of which give you early warning of problems by getting hot if you're watching. Okay.
Yeah.
That's sort of the gist of it, is that the historical method of doing this, I would emphasize the word periodic as that periodic maintenance, where they will, a utility, for example, will have a regular inspection regimen that may at the most frequent be monthly and is frequently just annual or maybe twice a year. They will send a crew, typically 2 or 3 guys with handheld instruments, and they will go out and they will measure every bolted connection, every piece of equipment in that substation. And then, in the olden days, and those days are still with us in large part, just write that data down on a clipboard, then bring it back and key it into a spreadsheet. And that's pretty much where it ends. And so that method is certainly better than doing nothing.
Yeah.
But there is a lot of room for improvement. And most of that improvement can come if you just increase the frequency of those samples. So our approach is to install automation equipment in that substation, along with the thermal imaging camera, and it will automate the acquisition of those measurements, automatically extract the temperature data, and then insert it into a database for analysis where we can run that algorithm I was telling you about.
Yeah. Okay.
And so now, instead of, 1 or 2 samples or 4 samples a year, we can give you 1 a minute.
Yeah. That's crazy.
So while you might not need 1 a minute, the point of that is to say, the more frequently you take a measurement, the more likely it is you're going to detect a transient. And when you look at the odds of how often transients occur versus how often people are manually inspecting, they almost never intersect. So
Sure.
Having persistent monitoring really gives you much richer data, and it actually allows you to do the sort of analysis where you can predict the remaining life of different assets, where you can recommend that you think this thing is going to fail within this amount of time. That's sort of the holy grail of predictive maintenance, is being able to make reasonably credible and truthful predictions about the condition of things.
Yeah, I was just gonna say, I thought my mind was gonna go to asking you how that benefits the, the substation or the electric delivery station in more of a sense of just saving time and saving manual labor. And my mind was going to maybe it's actually optimizing the equipment or, keying into like certain like, things about the life of the equipment or maybe what they can even do with settings or save, I have no clue on that end, but maybe they can actually even prolong the life of their equipment too by using your data as well.
That's exactly right. There are a number of ways you can use that data. One is to extend the life of aging assets that are very difficult to replace. The other is when you are pressed to produce under contract a certain amount of power, you can then at least make an informed decision about how much of a given asset's life you're prepared to trade for the instantaneous need that you're going to meet. That is the ultimate trade-off. You can run equipment over its rated, maximum, sometimes considerably over that and for a considerable amount of time, but it is not free. That is paid for at the end of that piece of equipment's life. So having good information about how often you have been doing that allows you to avoid unplanned outages. And that's the main driving factor behind all of this, is to eliminate or reduce unplanned outages. And that is what runs contrary. I referred in the preamble to this perverse incentive. There are different economic incentives at different layers of that pyramid that I described to you.
Yeah.
And, at the bottom incentive, the co-ops, they are where the grid meets the customer typically, and they have the relationship with what are referred to as ratepayers, which is an interesting term I've always thought, rather than customer, right? So they have, in many cases, greater political or customer relations consequence because it doesn't matter whose fault it is the lights went off. They're the guys who get the call, right?
Correct. Yeah.
And it may be a layer above them in the grid. It could be one of the transmission operators has a fault somewhere, and there's no way the customer is ever going to know that. So the incentives are different, and also the way that revenues for utilities are regulated, it provides an incentive to spend capital and a disincentive to spend operating and maintenance money. And that's because they are a quote unquote monopoly within their market space generally, even after utility deregulation.
Have
Right. So, as part of that, the bargain of being granted that monopoly, they can't set the rates. They have to apply to some regulatory body to say, this is what you're going to pay us per kilowatt hour. Right. And so that limits in ways that normal businesses don't have. You can be creative and think, oh, I'm going to go do this other thing and have a whole new line of revenue. No, you can't do that here. You're here to deliver the power, and you do that, and this is how much you're allowed to make. Part of that bargain is that they are incentivized to spend capital to build out the grid. Now, that's not an obviously bad incentive, right? It seems like a good incentive. And they are incentivized to the extent of actually being allowed to put a markup on all the capital they spend. And that markup can be anywhere from 5 to 20%. Just for having spent the money, that ends up going into their coffers. On the other hand, every dollar that they spend to keep that thing they purchased working goes against their profit and loss statement. It's an expense. And so they have an incentive. Really, when you put those two motivating factors together, there is a strong incentive, except in the most extreme political or safety conditions, to allow assets to run to failure.
got it. Yep.
Now, the dynamics recently in the market are changing because of the incredible growth in demand, predominantly forced on us by AI. And so there is huge competition for all of the things that make up the grid, the transformers, the switches, the copper wire, the towers. Every bit of that there is way more demand for than there is supply. So if you are, and especially if you're not a utility, if you're a business like a steel mill, an electronic arc furnace steel, that transformer is the heart of your entire business. A typical small electric mill will produce about $3 million, electric furnace mill will generate about $3 million a day in profits. The transformer that runs that facility probably costs, I mean, it's not cheap, but it's, when you're making 3 million a day in profit, you can afford to have an expensive transformer. Let's say it's $2 million. That's not the bad part if it fails. The bad part is you can't get one for 4 years.
Jeez.
So now you have 4 years times 3 million a day, you're out. Holy cannoli, right?
Yeah.
So, so okay, by contrast, right?
Yeah.
They do not want to run to failure. Even though they can afford the transformer, they can't get it.
Got it.
So,
So are you coming in and helping them basically figure out when that 4 years or when to start buying that purchase or whatever to alleviate downtime?
well, no, it's more to catch the precursor events to prevent it from getting there, because these are assets that operated properly 20, 30 years. Oh no, you don't want to be buying them every 5 years.
Yeah, for sure.
Can be it can be a plumbing problem that destroys it in one of these places because they're water cooled. If you have a problem in your plumbing and it gets obstructed or you get a leak, you can overheat. And the problems we've detected, we detected one of those, a clogged cooling pipe made a transformer run hot. Another case was the switchgear. I would say the switchgear is the and this is pretty much universally true everywhere you go in the power delivery system. Switchgear is the first place that you're likely to generate problems. These can be very simple mechanical manual switches. Lead out from that all the way up to motorized big, the ones you see on YouTube where the arms go up and down and the lightning bolts fly out. Those are called motorized disconnects. Those are a common source of problem. Um, in substation equipment, there's a thing called a bushing. And if every piece of high voltage equipment has, at least a couple of these, two per phase, one in, one out. And so a three-phase transformer will have six of these. And statistically, 30% of transformer failures begin in those bushings. So that's something you just want to watch. And then you also want to watch the performance of the cooling system. Is the radiator shedding heat at a greater rate than the main tank is generating it? And you can do comparative analysis stuff to figure that out. So um, those sorts of problems are the ones that we solve, and we have applied it to a wide variety of different now thermal imaging cameras. With our software, we're able to use lower resolution, less expensive cameras in some cases. And we've just recently introduced a new product called HeatWave, which solves a couple of interesting and persistent problems in measuring high voltage equipment. It's known, and accepted that thermal imaging cameras do not give you super precise measurements. They can under ideal circumstances, but getting ideal circumstances can be a real challenge.
Hmm. Interesting.
Are we? I'm hearing a bunch of noise in the background.
You should be fine. Yeah, it edits all out pretty well. It might be a little annoying, but for a second, you should be good.
Okay. So anyway, this new product we have called HeatWave actually is a wireless, battery-free contact temperature sensor. And so you think, okay, how does that work, right?
Yeah.
And why is it important to be wireless and battery-free? Well, when you think about deploying any kind of solution at utility scale, you're talking about thousands and tens of thousands of units. There are 60,000 some odd substations. On average, they'll have like 2.3 transformers and then all the associated. So there are hundreds of thousands of things to be measured in the grid. And thermal cameras, as we mentioned before, are pretty expensive in terms of cost per measurement, especially if they're not the kind that move around. So you have a fixed field of view. You can measure, I don't know, maybe a dozen things in that field of view. And that camera will cost, at a very minimum, $2,500 for the least expensive and capable one, up to 25,000. With this new technology, provided you can get within 25, 30 feet of the thing you want to measure, we can do it for a small fraction of that price with no correction required. It's a contact measurement, so it's completely accurate. There's no correction that needs to be made to it. There is no maintenance required, and it will operate. You put it in, and you can forget about it for 10 years.
Interesting.
Yep.
That's awesome. So what with that new technology, that you guys, just created. Kind of where do you see your business going from today, into the future? Kind of what is that going to open up? How is that going to change kind of what you guys do and help?
Well, in a couple of ways. This has been a breakthrough we've been working towards, as I said, for a couple of years now, in trying to figure out a way to get down to that second to last strata of the pyramid, the co-ops, the municipal guys, the small regional utilities, and have a solution that is inexpensive enough to acquire on the capital side and reliable enough not to increase their O&M costs, which with headaches and repairs and stuff. We now have that, and we've just completed our second deployment of this in the last month and a half. The first was here in North Carolina with a co-op called JOMAC, Jones Onslow, and we instrumented a radiator and recloser banks on their distribution substation. And then just last week, we instrumented 10 transformers at the Atlanta airport, which is our flagship installation. We already have over 100 thermal cameras all throughout the power delivery system of that airport, monitoring every splice and bolted connection. And now they've expanded it onto the transformers for the concourses as well,
Interesting.
using this new sensor tag capability. Yeah, and it's super easy to install. We did 10 of these things in one day.
Huh, that's awesome. Yeah. I mean, do you see like the type any of the increase of like EV, car, solar, all that good stuff? Like, is there a way for you to help that industry? Is that going to change what you guys do at any way?
Well, there are certainly opportunities there. Each of these areas that you just mentioned has a slightly different variation on the same problem of stuff gets hot before it fails. In solar farms, for example, and this is an interesting problem. We've been working with Entergy and a couple of other vendors on a scalable solution. But scalability, especially when you're talking about solar farms, it's essential. I don't know if you've I hadn't until last year actually seen in person a 100 megawatt solar farm. It's panels to the horizon.
Yeah.
I mean, it covers a huge amount of real estate. Place we were looking at had, I think it was 560,000 solar panels
Jeez. That's a
in arrays built. It was 23 generating circuits with 560,000 panels among them. And now think about this. There's an interesting stat. So every panel has two connections, right? And they have this special solar panel connector that's supposed to be impervious to weather and easy to install. But just the sheer numbers alone, two connections times 500,000 panels, there are 1 million connections just on the panels alone. What do you think the likelihood of there being no defects in manufacturing or poor workmanship in connecting 1 million solar panels?
yeah. There's no way.
No way. It's a huge problem. And I'm sure you've seen on YouTube, and if you can't, you can go gorge yourself on these videos of solar panel fires that take down buildings, burn up hundreds of acres of land. Once these things catch on fire, you cannot put them out
Yeah.
for two reasons. First of all, the substrate is basically fiberglass. Or just like
Yeah.
a boat, or if you ever seen a boat catch fire, it burns. You let it burn. There's no putting it
Yeah.
out. And the other problem is that as long as there is light reaching that solar panel, it's producing electricity. So if you have an electrical problem in the wiring, you can't shut off the electricity to fix it.
That's
You have to
crazy.
wait. You have to wait till it gets dark. Or in some cases, they make big blankets that you take
Like,
out and put over the solar panel. Give me a break.
yeah.
So
Yeah. But if it's on fire, you can't put a blanket over it.
anyway, we have patents on a solution for that problem, and we're looking for a solar panel manufacturer company who would be interested in licensing that, because that's not something we could manufacture at scale.
Yeah.
But I have an interesting solution to that, which I won't talk about in public yet, right? But just to say that we think we figured out how you could turn off the power to a panel,
Interesting.
and that could be worth something to somebody.
Yeah. Absolutely.
So okay, so that's at the very extreme end of the solar thing. All of those panels feed into things called inverters. And then solar panels produce DC power. And that's why it's hard to interrupt it, right? Because it doesn't alternate on and off. But you also can't put DC power into the grid. You have to turn it into AC power. And that's done with a thing called an inverter. And those inverters will then, they're wired, you hook them up to the grid, and they follow the frequency and the timing of the grid so that it's generating power that integrates nicely into the existing systems, right? Those inverters are notorious for catching fire. And sometimes, and along with every inverter, there's a transformer. Sometimes that affects the transformer and causes the transformer to fail. So these little wireless sensors that I was telling you about work
Yeah.
perfectly inside an equipment cabinet, inside of a transformer. So we can instrument very quickly and economically all of those pieces of equipment. And they're worth about $1.5 million a piece. So it's a good investment to just measure the temperature on the terminals,
Yeah.
those things, right? So yeah, there are lots of different applications for these.
Yeah. That's awesome. I mean, I think your target market obviously is like just a massive opportunity that you guys can kind of go after. So, right now, speaking of that, with your guys' growth and kind of where you're at now, like what challenges are you having targeting or getting new clients? Is there any type of like bottleneck that you're having? Have you have a solution? Any issues there?
Well, I can speak to the parts of the business where I have enough experience to know what the obstacles are. And that's in our traditional, the higher end space. And the obstacles there, well, let's take airports, for example, right? So we have a fabulous solution that is tried and true, proven true at Atlanta Airport. That's the world's busiest airport. And they had an 11-hour outage that ended up costing all of the concerned parties, airlines, vendors, et cetera, nearly $100 million. And it was in the wake of that that they came to us and asked us to help them design a solution that could scale out to a facility of that size. And so we did, and we did 6 months worth of testing with them and a professional organization called EPRI, Electric Power Research Institute. And together we crafted a solution scaling our basic product up so that you could have virtually hundreds of cameras simultaneously being monitored. One of their requirements was that this had to operate within their private infrastructure, no cloud, no off premise, everything on their private fiber network and in their data centers. And so that was a unique challenge that none of our competitors really was able to meet.
It's awesome.
And so since we've installed that, we have detected half a dozen, it's been almost 5 years now, half a dozen similar precursor events that were detected and remediated, and the lights never flickered.
That's awesome. That's
So
huge.
they are a very happy customer, and they give us a great testimonial. They just expanded that system to include the Mercedes-Benz Stadium in Atlanta, where we're
Nice.
now monitoring the transformers there. And why for that? The FIFA World Cup is going to be playing there.
Oh,
So
awesome.
we don't want the lights to go out during the
Huh.
game.
Yeah, for sure.
And then, okay, so what are the obstacles? The obstacles are identifying the pertinent decision makers and understanding the economics that drive their decision making process.
Got it.
Naively, I thought after this big success and a fair amount of publicity that we got associated with the Atlanta Airport project, I thought, okay, and you see it in the news with some regularity. This airport just had a power outage. That airport just had a power outage. There aren't that many different reasons why this stuff happens, and you can isolate the parts of the network that are critical and be monitoring stuff, but almost nobody does. And so I thought, okay, we'll just publicize this, and other airport authorities are going to, for sure, come knocking on our door. No, not one. So I said, okay, maybe we need to be a little more proactive. Well, here is the rub. No one appears to think that they are responsible for this problem. It's not the airport authority. It's not the utility. I mean, nobody wants to like say, oh yeah, that's my problem. I'm ready to spend a few $1 million to solve that.
Yeah, for sure.
Right. And that was true to a degree as well with Georgia Power and the Atlanta airport, is that I think there was sort of an awakening that came on both parties, both the airport authority and the utility and the stakeholders, the biggest stakeholders, Delta Airlines, they took the biggest hit of all. So there is definitely a need, but another contributing factor there is that most of the capital spending for airports is done out of a thing called the Aviation Trust Fund, and it's funded by gas taxes or something, but that's where all the construction money for airports comes from. There might be some local matching, but almost all federal money. Well, that money is programmed out 10 years in advance. So there's no
Yeah.
coming in there with a really clever idea to say, hey, I can fix that problem. Well, you're not in the plan. Sorry. So now you got to work to get in the plan for 10 years from now. That tends to drop this in priority,
Yeah. Sure.
right?
Yeah.
So that's
It's a long sales cycle
it is. It is.
for sure.
And I think to a lesser degree, that same sort of principle applies elsewhere. Within the utilities themselves, it is this really sort of unholy conflict between reliability and profits. It just is what it is.
Yeah. Unfortunately. Yeah. It's hard to really convey the value that you bring probably without like a major event like that or something to really show their pain
Bring
without,
the focus to it.
yeah.
And those circumstances sort of help you figure out in the moment whose problem it is.
Yeah, for sure. What I typically go on like a 6 to 12 month kind of, outlook, but where do you guys want to, with all that being said, everything that you're coming up with, you know, what's the future look like? Where are you guys going to really start focusing, your time and energy on? Is it that new product, and kind of where do you want to be in maybe like, 3 to 5 years?
It is, I would say that this new product has the potential to let us grow much more quickly because the barriers to entry are lower. It's easier to reach the people at the co-ops. They're not a huge monolithic organization. They're typically organizations of, no more than a few hundred people. And there is broad applicability of this and at a price point where the economics actually work. So yes, I think that in the foreseeable future, all of our growth focus, I mean, we continue to plant the seeds and water the seeds of the
Mhm.
big projects with the big utilities, but we just have no control over the timeline there. Whereas with these smaller ones, they're more approachable. And we've started a project with a company that produces all the power for one of the largest co-op. It's like a co-op of co-ops called Touchstone. We're instrumenting their generator transformers. So in their case, we can touch both the very top and the bottom end of the grid because they are an end-to-end supplier.
Interesting.
And so they're going to be a big piece of our focus. A small office in Colorado, and so we're focusing. They're handling the Midwest and West. And we're hoping this time next year we'll have 20, 30 co-ops using this, evaluating it, and it's hard to predict the future, but that's sort of what we're shooting for.
Well, awesome. I appreciate everything was like super interesting. I love the conversation. How, if there is a co-op or, one of those bigger guys listening, kind of how can they get in touch with you and, set up that appointment?
Sure. So our website, power-intelligence.com, there is you can, first of all, browse it, peruse it, and then you can request a contact and we'll get an email about that. We have an 800 number. I'll give it to you afterwards.
Yeah, I'll put it on in the description below. But all right. Well, thank you so much for joining. It was a pleasure.
Likewise, Alex. Thanks so much.